Okay, we're going to try this again. Take 482. Thanks to Mr. Vernick. Okay, we're going to start off with the notes that we talked about on Thursday. I'll review that real quick, and then I'll fill this in like I normally do. I put the notes on Google Classroom already filled out for you, like what you would get if you were absent. Feel free to just read those instead. I also put blank versions on there in case you want to fill this out like you normally would in class as I talk about it. Okay? Basically, section 1 and 2 that we talked about on Thursday focused on thermal energy, which is transfer of heat, okay, and kinetic energy, which is what temperature actually is, but we did talk about how they are connected. Okay? Thermal energy deals with the total particles that a substance has, and anytime you pass some of those particles, that is the transfer of heat. Conduction, convection, radiation are the three ways that that can happen. When something gains those particles, those extra total particles, now you have more packed into the same space. So they kind of vibrate back and forth and they're bumping into each other, which is also going to make them move faster, which will therefore affect their kinetic energy. So when something gains heat, obviously it also gains temperature. Okay? Section 3 is going to focus on how gaining thermal energy or obtaining heat can change the substance of an object. It can change its state of matter from a solid to a liquid to a gas. Okay? So when you put an ice cube in your hand, obviously it melts. Okay? Your hand has more thermal energy than the ice cube. It gives away some of that heat to the ice cube until they're the same temperature, and the ice cube melts. It goes from a solid to a liquid. So just to review the 3 states of matter, which you should definitely already know, we have solids. Okay, they have a definite shape and a definite volume, but the particles still vibrate and move a little bit back and forth. Okay, the same object or substance in liquid form can change its shape, but it will still have a definite amount, a definite volume. You have no idea how weird this is. There's nobody in here. I'm going to show you a picture of the contraption I had to make in order to get this going. The last one we have is a gas. Particles move very fast. They don't have a definite shape or volume. They're free to move around. Okay? The state of a substance, so whether it's in a gas, liquid, or solid form, depends on how much thermal energy that object has. The more thermal energy, we just talked about it, also the more kinetic energy, which means the higher the temperature is. Okay? So the more thermal energy, the faster the particles are going to move. Obviously, gas particles are going to move the fastest. So let's say we're talking about water. Water in the liquid form, okay, the particles are kind of moving freely. If you put that water on the stove and you gain thermal energy, you gain kinetic energy, and the temperature goes up, the particles are going to start to move faster and eventually turn into the gas version of the water. Okay, they will evaporate. Sure hope you can hear me, because I would hate to have to do this again. Okay, so matter, solids, liquids, gases, will change from one state to another if it releases or loses thermal energy, and also if it gains or absorbs thermal energy. So we're going to talk about the different conversions, okay? Obviously the easiest one is going from a solid to a liquid, okay? If something goes from a solid to a liquid, then it melts, right? Like the ice cube in your hand. It was a solid, then it melts into a liquid. The reason why it does that is because the solid substance, so we'll go with the ice cube again, gains thermal energy, the particles start to move around faster, and they turn into a liquid form. The temperature necessary for something to melt is called the melting point, and that is a vocab word, okay? Flip that scenario, you have water, you put it in the freezer, you are trying to change it from a liquid to a solid form. That obviously is freezing. Okay? The reason why it freezes is because the object, the water, loses total energy, thermal energy. The particles slow down and pack back in. Okay? The temperature necessary to make something freeze is called the freezing point. Okay? So we have going from a solid to a liquid, or going from a liquid to a solid. Okay? This is going to gain thermal energy. This is going to lose thermal energy. Okay. The next one then is going from a liquid to a gas, or from a gas to a liquid. Okay? Liquid to a gas occurs when particles will absorb thermal energy. They will gain thermal energy. So very similar to the solid ice cube melting and turning into a liquid, it gained heat from your hand. If you now take that water, put it in a pot on the stove, and apply even more heat, you will eventually turn it into a gas. It will evaporate. Okay? So going from a liquid to a gas is actually called vaporization, which is a vocab word, and then there's two types of vaporization. When it occurs at the surface, we call it evaporation. And when it occurs below the surface, we call it boiling. Okay? And then the temperature necessary in order to change something from a liquid to a gas to make it boil is the boiling point. Hopefully you can remember that. Okay? Vice versa then, we're going from gas, water vapor in the air. Okay, let's say you have a cold drink and you take it outside in the summer. Okay, those gas molecules are going to lose their thermal energy. The air is hotter. It wants to give some of that energy away to the cold cup. So it ends up looking like sweat on the side of your cup. Okay, condensation. Okay, so we have going from a liquid to a gas form, like the top of the lake here, which is vaporization, going from gas in the air to a liquid form on the edge of your cup, which is condensation. Okay, last one. This is probably going to be maybe the only one that you haven't talked about before. Sometimes if thermal energy is lost or gained so quickly, you can actually skip the liquid stage, which would be the middle stage. Okay? If you go directly from a solid to a gas, that is called sublimation, which is a vocab word. That's what dry ice does. Okay? It's like that spooky stuff that they use around Halloween. The reason why is because it goes right from the solid ice cube to like this foggy gas. Okay? And really it is so cold that it almost feels hot when you touch it. The opposite of that then would be going right from a gas, so like water vapor in the air, to a solid. Okay? Somebody needs to turn their phone off. That is called deposition, and the best example of that would be frost. Okay? Like on the grass in the morning, that was a gas form, and then the amount of thermal energy changed so quickly that it solidified and turned into frost. Okay? Okay, last part. As the thermal energy, the total energy of a substance increases, so it's gaining thermal energy, right? So it would be climbing up the ladder. So we'll put like solid, liquid, gas. Okay, so as you climb up the ladder, right, you are gaining thermal energy. Right, you are getting heat, things are melting, maybe even evaporating. As you are coming down this ladder, as things start to freeze and solidify, they are losing thermal energy. Okay, but as objects gain thermal energy, as their thermal energy level increases, okay, and the particles are going to, first of all, double, triple, whatever, you are gaining more total particles. so they bump into each other more and they move more, okay? The object that you're talking about, the substance, is going to expand. Okay, it gets bigger, right? If more people came in this room, the best thing that we could do is expand the walls, allow for more room for them, okay? There is one exception to this that we'll talk about in a second, but thermal expansion happens when things are heated. Okay? Girls, maybe your moms that wear wedding rings, this is very accurate. When it is cold, sometimes my ring will be able to turn all the way around and it feels too big for my finger. The reason why is because when my fingers are cold, they shrink. You guys have heard that before. When things are cold, they shrink. When things get heated, they expand. So like one time my mom came to my softball game in the summer, so her fingers were hot. They swell up. She took her wedding ring off. She left it in her cup holder while she watched my game. She got fast food on the way home. She picked up all of her trash, threw it away, threw her wedding ring away. She got a bigger, better ring. But the reason why she took it off is because when things gain thermal energy, extra particles, because of the heat, and they move faster, they do expand. Okay? The one exception to this, and maybe you've already realized it, is water or anything with water in it, like pop. If you ever put a can of pop in the freezer, it will explode. The reason why this happens is just because of the way the molecules are bonded, H2O molecules. They actually leave space in between, so there's air pockets. So if you put water or something in the freezer, you know, like an ice cube, it will expand. But the typical rule is when things get extra thermal energy, when they get heat, they expand. And then water is the one exception. It actually expands when it gets cold. Okay? That is why there's cracks in your sidewalk. It's not just like for looks. If they make your driveway or something, right, you have your driveway, they will like put the lines down the middle. Okay, you know what I mean, just the little slivers that they cut in it. The reason why they do that is so that when the seasons go from summer to winter and the concrete expands and shrinks, if it was just one solid thing of concrete, then it would crack itself. If you already allow for some space for the concrete to move, then it won't crack like that. Okay? Another good example of thermal expansion is a thermometer, obviously. If you ever have like an actual thermometer where you can see like the mercury inside, as it's heated, as it gains thermal energy, thermal expansion, the liquid, there's the same amount of liquid all the time, but it expands and it climbs up the tube and it shows you a higher temperature. Okay? So those are our notes. Again, I put a blank version on there. You can watch this, fill it out if you want. You can just watch this. I put completed notes on there if you want to just read them. You need to, by midnight, submit worksheets 6.1 and 6.2, which will focus on thermal energy, kinetic energy, heat, temperature, the different ways that heat can be transferred. And then you also, by midnight, need to take your 13-word vocab quiz, which is on there. That's it then. There is no homework that goes with this. I'll teach you one more section tomorrow, 6.4, about engines, and then your new vocab words and quiz will be on Wednesday.